Good day. Boys and girls, light travels roughly at a speed of 300 million meters per second. Let's write that down. 300 million meters per second. That is quite fast. Now, maybe you've seen this value. Instead of 300 million meters per second, your science teacher might have told you it's 3 times 10 to the power of 8 meters per second. Who's wrong? Who's right? They are exactly the same. So what is this lesson all about? This lesson is all about scientific notation. So boys and girls, what is scientific notation? Scientific notation is, I would like to have one number that's a non-zero, a 2, a 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the comma, and then everything else. So I would like to have one number that's a non-zero on the left-hand side of my comma. And that is exactly what we did here when we've changed the 300 million meters per second to 3 times 10 to the power of 8 meters per second. Okay, let's do an example and see if you understand. Example 1, 6,280. And my question is that you need to write this in terms of scientific notation. Remember what we said about scientific notation. One number that's a non-zero and then the comma. So I would like to have 6,28. Do you agree? Yes. Is it necessary to write that zero there? You can, but it will not change the value. Okay. So now to get to 6,28, what did I do? I actually divided this value by 1,000. Okay? So the 6,280, I say divided by 1,000. Now I cannot just divide and leave it like that because now I'm changing the value. So what am I going to do? Immediately I'm going to multiply by 1,000. Times 1,000. And now what's happening? This 6,280 divided by 1,000 is now actually becoming the 6,28. And then what's remaining? The times 1,000. Times 1,000. And now because this is actually part of exponents, 1,000 we can write as 10 to the power of 3. So it's 6,28 times 10 to the power of 3. Boys and girls, just check yourself. You had a big number. And if you have a look at your scientific notation, because we have a positive exponent there, it means that originally we had a big number. Okay, now let's do it other way around. Let's say we have 0,00032. And I want you to write that for me in scientific notation. Remember what we said. What is scientific notation? I would like to have one value, then the comma. So I would like to end with 3,2 something there. Okay, so to go from 0,00032 to 3,2, I'm actually multiplying. With what? 1, 2, 3, 4. It's 4 spaces, so I'm actually multiplying with 10,000 because it has 4 zeros. So it is 0,00032 times 10,000. Okay, but I cannot just multiply with the 10,000 and not divide with it immediately, otherwise I'm changing the value. So I will immediately divide by 10,000. So this will become 3,2. And now divide by 10,000. I can say, you know what? That is actually 10 to the power of 4. And I have my division. So I can say, okay, 3,2 divided by 10 to the power of 4. And remember, in the lessons earlier, we said that we can move a base with its exponent. If it's in the denominator, we can move it to the numerator. But then what will happen to the sign of the exponent? It will change. So this is the same as 3, 2 times 10 to the power of -4. Boys and girls, that negative number means that in my original number was actually a very small value. Okay, I have now a challenge for you. See what you can do with the following question. 2 times 10 to the power of 5 times 7,1 times 10 to the power of -8. Now I'm actually giving you values in terms of scientific notation, and I would like to see if you can work it out, but don't grab the calculator. Work it out as it is. Where will we start? Maybe it will be best by starting with the values, the ordinary numbers, without the exponent. So, the 2 and the 7,1. I can rewrite that. I can say 2 times 7,1 times 10 to the power of 5 times 10 to the power of -8. And now, 2 times 7,1, or think of it in terms of doubled 7,1, 14,2. That will be 14,2 times. And now have a look here. I have 10 to the power of 5 times 10 to the power of -8. Bases are the same. They are being multiplied. What do you do with your exponents? You add them. So it will be 10 to the power of -3. Is this now in scientific notation? Unfortunately not. This is not in scientific notation because I do not have one value and then the comma. I have two values and the comma. So I would like the answer to be in terms of 1,42. Okay, so I would like to have a 1,42. So I have a 14,2. To go from 1,42 and still have a 14,2, it's like I will multiply by 10. So if I multiply by 10, there, I will still have 14,2. Do you agree? Yes. And now there's still multiplication by 10 to the power of -3 times 10 to the power of -3. And what do? I have 1,42. That's what I would like for scientific notation. And now bases are the same. They are being multiplied. What do you do with your exponents? You add them. Careful. There is an exponent to the power of 1. And 1 minus 3, I know it's confusing. You might say, but we add them, and now I say -3. Remember, if you add exponents, it means that you leave the sign as it is. If it's a negative, you leave it as a negative. So I have 1 -3, 1 minus 3, and that will be -2. So times 10 to the power of -2. And there's your answer in scientific notation. Boys and girls, I know that there's a lot of different methods, and some teachers explain this a bit differently. Whether you should move the comma how many spaces to the right or how many spaces to the left, it doesn't matter as long as you understand what you are doing. Until next time, goodbye.